In this lesson, we are going to learn how to write the half cells, or commonly known as the half reaction, and we can balance those half reactions that we will later use on to balance a redox reaction. But for now, let's focus on writing the half cells. We know that Leo, the line says Ger, for Leo, where we have lose electron, the oxidation number going from reactant to the product become more positive because in oxidation you're losing electron, and remember electrons are negative, so of course the oxidation number become more positive because it's losing the negative electron, so keep that in mind. And for Ger, you have gain electron in reduction, and what happened to the oxidation number? The oxidation number become more negative, okay, because you are gaining the negative electron, so that makes sense. Now let's get back to an example problem. In this case, we know how to assign the oxidation number. This is 0 because it's the elemental state, the same thing as this one is also 0. Then we have Mg, that's +2. Then we have Br, each one of the Br is -1. So we look at this, let's look at Leo, let's look at losing electron first. So what we have here is Mg starting from 0, and it's going to become what? In this case, become positive. So it's becoming more positive, that means it's losing the negative electron. So we can have Mg, okay, notice how Mg is right there, it is 0 as the oxidation number, but we don't write down the 0. Then we have Mg +2. And notice how I take part of this compound, because we're not looking at the whole entire thing, but we look at Mg by itself. And in this case, Mg is losing 2 electrons. And that's it for Mg. And then we have bromine. Well, in this case, bromine start with 0 and all of a sudden become -1. That means it has gained the negative electron, so that's reduction. So of course we're going to have Br. Notice how Br, there are 2 Br, so that's very important because now 2 Br is involved in this reaction. So when we do that, we have to take account of the 2 Br. So we know that Br is gaining electron. Okay, we know it's gaining electron. And each of the Br gain from 0 to -1, that means gain 1 electron. But we have 2 Br, so that means a total of 2 electrons being gained. Okay, and notice how each Br right here is Br -1, but there are 2 of them, so that means there are going to be 2 Br over here. So that's how we do that problem. So be careful, don't get tricked. Remember, always assign oxidation number and rewrite it in terms of oxidation, but don't get tricked by the number of 2 right there, okay? Keep it consistent. Let's try another problem. Here we have this hydrogen and oxygen produce water. So in this case, this is 0, this is also 0, but for hydrogen, it is +1, and oxygen is -2. So in this case, let's look at hydrogen. Hydrogen is coming from hydrogen start from 0 and become more positive. So what does that mean? It has lose negative electron. So we will have oxidation. So we have H2, okay? Notice how I don't care about that coefficient 2, but I care about the subscript. So H2, it is losing electron. So in this case, we have H+. Notice how I don't write H2O or H2 right here, but I write the oxidation number of H, which is H+ right there, okay? And in this case, notice how we have 2 hydrogens, so this one must also be 2 as well. And each one of the hydrogen lose 1 electron. Since there are 2 of them, it must be losing 2 electrons. And that's all we have to do. Now let's talk about the oxygen. Oxygen start from 0 and all of a sudden become a -2. So it has gained a negative electron. Well, specifically, each one of those oxygen will gain -2, which means it's going to gain 2 electrons. But we have 2 oxygen there, so be careful with that. So we have O2, okay? So O2 is going to gain a certain number of electrons. Remember, each one of the oxygen gain 2, and we have 2 of that. So that means we're going to gain 4 electron total. And because there are 2 oxygen here, we know that the number based on the oxidation number of oxygen, or oxide specifically, is -2. So therefore, there must be 2 of -2 right there. So again, be careful of the subscript because there are 2 oxygen here, and each one of them, based on this oxidation number, it lose 2 electrons. Since there are 2, so it can lose 4 total, and since there are 2 here, there must be 2 over here as well. And the last thing is that notice how this is 4 electron. We need to balance this out. So multiply the top part by 2. That will give us 2H2 and 4H plus 4 electron. Now the number of electrons balance each other. Let's try another problem. Here we have Ag2S, so that means silver has a +1 and S has a -2, and then react with hydrogen, that is oxidation of 0, and over here we have Ag equal to 0 as well, and H is +1, and therefore sulfide must be -2. Now, notice how Ag has a 2 right there, but it is combining with sulfide, right? So what's the difference between when we have this and that? Just like going back to here, when we have this, we only focus on a single atom oxidation number. Where when it's this, we write down this, and we focus on 2. So make sure to know the difference between elemental and element combined in a compound. So let me show you how it works again, okay? So here we have Ag. The oxidation number for Ag, a single atom Ag, is Ag plus, okay? Now, notice how Ag is plus all of a sudden become a 0. That means it has become more negative, so therefore it has gained us a negative electron. So in this case, plus 1 electron, okay? And it's producing Ag. There you go. We're going to show you how that 2 will be back there later on. But for now, let's know the difference. So when it's in the compound, we don't care about the subscript, okay? Now let's look at hydrogen. It starts with 0, all of a sudden become plus. That means it has lost an electron. That's the only way it becomes positive, or more positive. So we have H2. Notice how I write the 2, because this is an elemental form, okay? It's not combining with any other element to make a compound. In this case, H is starting from 0, so it's gonna lose 1 electron. And notice how again, H2 is combined with sulfur or sulfide, and I don't write H2, instead I write the oxidation number of a single atom. In this case is plus, okay? And then because there are 2 H, that means there are 2 right there, and each one of them lose 1 electron, so I must lose 2 electrons together. Now let's go back to the 2 on Ag. Notice how this is 2, and we need to balance it out. We multiply this by 2 and give us 2Ag plus 2 electron equal to 2Ag. There you go. And that's all we have to do. Isn't that easy?